Hi everyone, I'm going to go over how to name our structures. For this week we are doing just alkanes, so when anything refers to as alkanes, please remember that these are single carbon bonds. Next week we'll go into alkenes and alkynes, and those will be our double and triple bonds. So briefly going to go down here to our first 10 alkanes. So if we have any CH4 group, so that will look something like this. So this is our methane, right? And then when we take this hydrogen off and we bond it to another carbon, now we have 6 hydrogens and 2 carbons. That is our ethane. Then you can take this hydrogen off again and bond it to another carbon and add the hydrogens, and this is our propane. So you keep going, right? So then you take this hydrogen off, bond it to another carbon, and this is our butane, so which has 4 carbons. What you see here is that the middle 2 carbons are the same, right? That's carbon bonded to 2 hydrogens. That's where you see in a short version written here CH2 sub 2. So we have 2 CH2 groups, and then we have the CH3 on both sides. So when we extend this to another carbon, if we add another carbon to the end here, right, now we get our pentane, and you see that this 4th carbon is just like the other 2 now. So that's where we get our sub 3 CH2 group from. So you keep going and keep going and keep going, and you'll get to the decane, which is our 10 carbon bond. In your assignments, I've drawn out the formulas in a line angle, so that's right here. So if we were to name this, right, we have a C, 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 and then we have first carbon gets a 3 hydrogen, second carbon gets 2 because it's bonded to 2 more carbons, and then the last one gets 3 hydrogens. So that's where you get the CH3, CH2, CH3 from. So I went over here how to name them if they're a straight line. So what happens if we have constitutional isomers? So constitutional isomers have same molecular formula, but the bonding is different. So here it's giving us an example of butane, so that's 4 carbons. So we have 1, 2, 3, 4 carbons, and the hydrogens are bonded to H. So our first will be CH3, then we have a CH2, followed by another CH2, and the last one is another CH3 group. And then here we have 2-methyl propane. So what happens there? So we pretty much have the same 4 carbons written differently. So we have 3 carbons, and then we have another carbon bonded to the center carbon. So now we have this carbon that has 3 hydrogens, this carbon that has 3 hydrogens, right? And then this carbon also has the 3 hydrogens. Now we have this carbon bonded to 3 different carbons, therefore we can only put 1 hydrogen there. So if you number your carbons, let me use another color. So we have 1. You'll number them to the longest string. So we have 1, 2, and 3. We see that on the second carbon we have another carbon attached. So that's where you get this 2 from. The 2. Let me zoom in. You see it says 2 methyl propane. And at the second carbon we have a methyl group attached. That's the CH3. So we have 2 methyl, and then the propane is 1, 2, 3 carbon chain. So that's propane. If we had moved this methyl group to here, then it'll look just like the butane. Let me do another example here. Here are the prefixes if you need. So, for here, this is a methyl group because we have 1 carbon, right? Here it shows you the number of carbons. We have 1, so that's a meth. 2 is an eth. 3 is propane. There's an example here. Here's a longer chain. We have 8 carbons. So what is 8? Do you guys remember? That's the octane. And then we have on the 4th carbon, we have a methyl group that's attached. That's a CH3 group right here. You see that? So that's where we get the 4. We have a methyl group. And then we have the long string, which is the octane. So if this CH3 here was bonded to another, so let's say this was CH2 and that was bonded to a CH3 group, that's where we get our ethyl name from. So if it was that, then it would be called 4-ethyl octane. And if that was another CH2 group and that was bonded to another CH3, so now we have the 3 there, 3 carbons, that's where you get the propyl from. So then it would have been called 4-propyl octane. Octane is saying because we have the 8 carbons here. You see that? So here's another example for number 4. You see here we have 1, 2, 3, 4, 5 carbons, and on the second carbon we have a methyl group that's attached. So how do we name that? We put the 2 for the second carbon, 2, and then we have the CH3 group, that's the methyl, and then we have our 5 carbon chain, that's the pentane. So everything ends with an ane in our alkanes because everything is a single bond, right? All the bonds you see here are all single bonds. So here's another example. We have a 6 carbon chain, and on carbons 2 and 4 we have a methyl group. So how do we name that? So you start off, let me redraw this. So you have to number your chain wherever your first bond is the least connection attached to the chain, the longer chain. So if you were counting 1, 2, 3 from the left side, and then we can do 1, 2, 3 from the right side. So you see how for the navy, our first methyl group is at 3, and for our red, our first methyl group is at 2, right? So 2 is smaller than 3, so that's why we have to go with the red counting and not the navy. So we start from the left, we have 1, 2, 3, 4, 5, 6, and on 2 and 4 we have a methyl group. So we have 2 methyl groups on this carbon chain. How do we name that? So we don't say 2-methyl, we say dimethyl. That's where we get the dimethyl from. So we have 2, 4, then you put a dash, we'll put the dimethyl, and then our long chain has 6 carbons, and what is that? That's a hexane. So we'll put hexane. So if I redrew that, right, we have our 2 methyl groups, and let's say we have another methyl group here. So how do we number that? Our first methyl has to be on the first carbon, right? So we can't have our first methyl be on the second carbon and ending the 6th one with a methyl group. So we will number it from the left side, 1, 2, 3, 4, 5, and 6. So now how do we name this? We have 3 methyl groups, right? We have 1, 2, 3 methyl groups, so that is not dimethyl, that is trimethyl. So we have 3 methyl groups. Where are they located? They're located at carbons 1, 3, and 5. So we write 1, 3, 5, dash. Then we put the trimethyl. And then our long carbon chain, the 6th carbon, that is hexane. So if I work on this problem again, so let me do another one. So we have 1, 2, 3. This is the same as before, and then I have another one here, right? So now we have 1, 2, 3, 4, 5, 6. We still have our 6 carbon chain, but now we have a methyl group. We have a methyl group present here. So how do we number them now? Because the first 2 are at the beginning, we start off on this side again. So 1, 2, 3, 4, 5, 6. Instead of having 1 here, because then we don't have 2, right? So that would be 1, 2, 4, 6. We have a problem here if you look. So we start off with our numbering, right? We're starting from the left side because the first group bonded is to the 2nd carbon. The 2nd carbon from the right side does not have anything bonded. So we have at 2, we have 2 ethyl groups, right? And then at 4, we have an ethyl. Oh, sorry, these are our methyl groups. I confused myself. And then this is our ethyl because we have a CH2, CH3. And these are just the CH3. So we name these 4 ethyl, and then we have our 2 CH3s, so we have 2 and 2, so that would be 2, 2, and remember that's 2, so that's di methyl, and then we have our long carbon chain, which is 6 carbons, and that is hexane. So if we have 4 carbons bonded to form a square shape, that is called a cyclobutane. And then the 5 is cyclopentane. So cyclo means we have a circular formation, right? And then if you have 6 carbons, that is cyclohexane. Other naming, so these are the envelope conformation, the chair conformation, okay, so I think this is one of your homework problems. To name the, but you guys can just see that. Any other namings? Okay, that's it for namings for the alkanes. So please, once you're finished with viewing this video, please work on the file that I uploaded and submit that on Canvas. You just have 4 molecules to name. If you have any questions, please email me and I'll get back to you as soon as I can.